True Projects. In this video, we are going to explain about the project that is a big data-driven hybrid model for enhancing streaming service customer retention through churn prediction integrated with explainable AI. So before getting into the execution, first let us understand what is the project about. What is customer churn? Customer churn is basically when customers they decide to stop using a service. And this can be a big headache for streaming companies. Imagine a platform like Netflix or Spotify. If too many users start canceling their subscriptions, it will not only just lose their individual customers, it will also lead to less revenue, lower customer lifetime value, and also even it will damage their brand reputation. And people, they don't just stop using a streaming service overnight, it happens gradually. They might start watching less, they may be skipping renewing their subscription, or they may be switching to a competitor with better content or pricing. And when too many users do this, it becomes a major issue for streaming companies. And this leads to revenue loss and also decline in customer loyalty. A high rate, that is, high churn rate, can also make a platform look unreliable, making it harder to attract new users. And the other thing is, for businesses, for keeping existing customers is always cheaper and smarter than constantly finding new ones. So, acquiring new users takes a lot of marketing, promotions, and discounts, while retaining current ones, that is, current customers, just require understanding their needs and also keeping them happy. That's why predicting churn is such a big deal. If a company can spot the warning signs early, like reduced engagement, frequent complaints, or switching to a cheaper plan, it can take action to keep those users from leaving. By analyzing customer behavior and figuring out what drives their decisions, companies can create better retention strategies, improve their services, and also build long term customer relationships. And coming to the prediction part, predicting customer churn isn't as simple as just looking at whether someone cancels their subscription or not. There are many factors that come into play. That is, how often they use the service, whether they are satisfied with the content or not, or if they find a better deal elsewhere. Streaming services deal with millions of users, each with different behaviors. So, spotting patterns that indicate someone is about to leave is tricky. Traditional methods often fail because they treat all the users same, missing out on important behavioral trends. And the other thing is, if a company can't accurately predict churn, it risks losing valuable customers without understanding why. This is not only means a drop in the revenue, but also the higher cost in trying to attract new subscribers, marketing promotions, and special offers to bring in the new users that can be very expensive. And if churn keeps happening, it becomes a never ending cycle. That's why having a strong churn prediction system is so important. It gives companies a chance to take action before users leave, helping them improve retention strategies and keep their customer base stable. So this project, to overcome with all these issues, it takes a smarter approach to predicting customer churn by combining both the machine learning and deep learning models, calling it as a hybrid model. So here we are integrating both machine learning and deep learning model, making it a hybrid model. So instead of just looking at the user data in a static way, here we use LSTM. So here we are using LSTM, that is long short term memory and gated recurrent unit, to track how a user's behavior changes over the time. And these models are great at recognizing patterns in sequences, like how often a customer watches content, whether their activity is decreasing, or if they have started skipping months. Once these deep learning models process the data, these insights are passed to the light GBM model, that is light gradient boosting model, which is the machine learning model, which makes the final decision on whether a user is likely to churn or not. So here, these both are the deep learning models, and this one is the machine learning model. And not all the data is useful when predicting the churn. Some features matter more than the others. That's why the system first picks out the most relevant features, that is most relevant factors, using two techniques. So here we are using both the techniques, that is chi-square testing and sequential feature selection model, that is sequential feature selection model. So we are using both of these techniques to select the most important features. Chi-square, it helps to identify which features have a strong relationship with the churn, while this SFS selects the best performing combination of those features, ensuring the model doesn't get overwhelmed with the unnecessary data. This is the feature selection part. And moving to the other part, since churn is usually imbalanced, that means with far fewer churned customers compared to the retained ones. So for that, this project applies, that means this proposed system applies SMOTE, that is called synthetic minority oversampling technique, to create a more balanced data set. This prevents the model from being biased towards the majority class. And once the data is refined, it is ready. It is processed through LSTM and GRU, then which specialize in capturing how user behavior changes over time. These learned patterns are then combined with the selected features and passed to the light GBM, which makes the final churn prediction. And to make the selection decisions, that is, to make the model's decisions more understandable, the system uses SHAP. So here we are using SHAP and LIME, that is Shapley additive explanation, and LIME refers to local interpretable model agnostic. So both of these are used to explain why a certain prediction was made. This helps to businesses not just know who might leave, but also why. So they can take the right steps to retain the customers. So this is the proposed system part. Now to further improve the performance of this project, here we have incorporated two models as the extension. One is the voting classifier, and the other one is CNN with LSTM. So coming to this ensemble model, that is voting classifier, so instead of relying on a single model, this method combines two powerful boosting models, allowing them to work together and make more precise predictions. On top of that, here we have also incorporated a hybrid model, that is CNN LSTM. It is introduced where CNN captures important features, that is important patterns in the data, while LSTM tracks changes over the time. This makes the system even more effective at spotting potential channels. And to make the system even more easier to use, a front-end interface is developed, that is using Flask. So here we have developed front-end using Flask framework, which allows users to interact with the model effortlessly, whether it is testing predictions or analyzing results. The interface provides a smooth experience. To keep this secure, user authentication is included, ensuring that only authorized users can access the system and personalize their testing. Now, moving on to the implementation. To implement this project, we have followed the steps which are mentioned in the flow of work. So, let's understand how we have implemented the project. So, first, we have loaded all the necessary Python libraries for data handling, pre processing, model training, and evaluation. Then comes exploratory dataset part. So, here in the second step, we load and examine the dataset to understand its structure, feature distribution, and the missing values. Then comes data processing. Here, we identify and remove duplicate entries to ensure clean and accurate data. And then we eliminate unnecessary columns and handle missing values for better model performance. Then comes label encoding the data. So here we convert categorical features into numerical values using label encoding for compatibility with the machine learning models. Then selecting X and Y data. Here we define the independent features as X and the target variable Y, which indicates whether customer will churn or not. Then comes SMOTE over sampling. So here we apply synthetic minority oversampling technique, that is nothing but SMOTE, to balance the dataset by generating synthetic samples, that is synthetic examples for the minority class. Coming to the feature selection. So here we have used two techniques, that is chi-square feature selection and also sequential feature selection, that is nothing but SFS. So coming to this chi-square feature selection, by using this, we can identify the most relevant categorical features based on their relationship with the target variable. And by using this SFS, we iteratively select the best performing subset of the features for model optimization. So here in this project, we will be doing prediction using the features extracted using this chi-square, and separately features which are extracted using SFS, we will be doing the prediction. Then coming to the other part, that is splitting the data set. So here we divide the data set into two sets. One is training set and the other one is testing set to evaluate the model performance on unseen data. So training data is used to train the model and testing data is used to evaluate the model performance on unseen data. Then comes building the model. So here in this step, we implement different machine learning and deep learning models, including LSTM, GRU, and light GBN. So here we will be defining the models. Then comes training the model. So here we train models on both the original and smooth balanced data set to compare the performance. And then comes comparing the model. So here we evaluate models using key metrics such as accuracy, precision, recall, and FN score. Then comes comparing graphs generated. I mean, they are generated with the scores of all the models. So here we visualize the model performance by plotting comparison graphs of all the evaluation metrics. Then comes the development of the front end. So we have built a Flask-based web interface that includes registration and login functionality using SQLite database. And users, they will be able to input the feature values in the front end that will be pre-processed at the back end, and it will be fed to the train model. Finally, train model will be giving us a prediction whether customer will churn or not, and that can be visible through the front end of the application. So this is how we have implemented the project. Now moving on to the algorithms used. These are the algorithms which are used in this project. So here we have used RNN, LSTM, GRU for comparison purpose. And this is the proposed model that is combining LSTM, GRU with the light GBM model. And this is the extension model. Here we have built light GBM, XGBoost, CADBoost, MLP, logistic regression, and random forest for the comparison purpose. And here we have extension voting classifier. So this is the extension model, which has performed well among all the models built. And to implement, we need two kinds of requirements. One is hardware and the other one is software. So coming to hardware, we need operating system of Windows, processor of 5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Coming to software, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework Jupyter Notebook, database SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is the overview. Now let us execute. To execute, we are supposed to open the code folder that contains source code files. So let's open the code folder of the project. So these are the source code files in the code folder of the project. Let us understand each of them. How will they be used in this project? So in the first folder, that is models folder, here we have algorithm information that is stored in .h5 files, numpy files, and pickle files, and they will be loaded into the project code during runtime of the application. And in the static folder, we have folders consisting of files related to CSS, JavaScript, and Bootstrap files, which are important for the visual appeal. And here we have templates folders. So in this folder, we have all the HTML pages used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And this is app.py file. So this .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. And here we have two Jupyter Notebook files, which contain a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, which makes it a popular choice for the data science. So here we have two Jupyter source files. So in this Jupyter source file, that is in this Jupyter Notebook file, we will be loading the data set and we will be extracting the features using chi-square, and we will be predicting customer churn on the features extracted using chi-square. Similarly with the SFS feature selection technique also. And here we have sample file in which we have test cases that we will be using in the front end for prediction purpose. And this is the signup.db file. This file is a database file which is used to store the user information. And this is the data set that we have used in the project. Let's open it. So this is the data set that we have used in this project. So this is the customer ID column here we have, and similarly we have all the attributes that are important for the customer churn. So here we have, these are all the features based on which we will be predicting the customer churn. So these are the features. We have customer ID, gender, senior citizen, whether they are partner or not. And here we have dependence, tenure, phone service, multiple lines. Accordingly, we have the multiple attributes. And this is the target column that we will be predicting in this project. And this data set is used to train the models for predicting the churn. Let's close this. And now let's execute. So to execute, copy the path of the code folder from the address bar of the file explorer. So I'm copying the path. Now open the Anaconda prompt. So it is open, give the command cd, give the space, and now paste the copied path. Here you can observe that path is copied, right? Now click on enter. Here if you observe, current directory is changed to the code folders path that we have copied just now. And now we are supposed to compile app.py file. So give the command python space app.py, that is the front end file, and now click on enter. This command is used to execute the Python script and perform runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port unless configured differently. So this is the local host and this is the port. Now copy this local link provided by the Flask framework and paste it in any web browser. I have copied it. I prefer Google Chrome, so I will paste it in that. Paste the link here. Click on enter. So this is the web page of this project, which is displayed in the browser, and this is developed using Flask framework. And now we need to sign up first. So click on sign up. Here you can see, right? Sign up button, click on that and enter all the registration details if you are registering newly. I have already registered, so I will directly sign in. Click on sign in and here provide username and the password. Click on login. We have logged in successfully and we are redirected to prediction page of the project. As I have already told you that we will be doing prediction for both the features selected. First we will be doing prediction for the feature selected using chi-square. So click on that. Here, these are the parameters that we are supposed to give as input for the application. Based on that only, we will be getting the prediction whether the customer will churn or not. So let's understand what are the parameters we have. The first one is the tenure. It is the total number of months that the customer has been subscribed to the service. As shorter tenure may indicate a high likelihood of churn. Then comes online security. It indicates whether customer has opted for online security services, whether it is yes or no. And customers without security features may be more likely to leave. Coming to online backup, here it represents whether the customer has an online backup service or not. Having backup services may increase retention. And coming to device protection, it shows if a customer has a device protection plan that is yes or no. Customers without protection might not see enough value in the service. Then comes technical support. So it indicates whether customer has access to technical support, whether it is yes or no. Here we will be giving. So lack of technical support could contribute to the churn. Then we have contract. It specifies the type of subscription contract. Longer contracts often indicate lower churn risk. Then we have monthly charges. So the amount of customer is billed each month. Higher charges may lead to the dissatisfaction and churn. Then we have total charges. The last one we have is the total charges. So it is the total amount paid by the customer since joining. High total charges may indicate long-term customer, reducing churn likelihood. So now let's enter the values. So let's open the sample file. Open sample file. And here we have test cases for the chi-square feature selection. So these are the inputs that we can give for predicting, and you can try with any other features also. Any other values also. So now let's give the values. So here in the last column, we have target. It is just to compare whether the application is correctly predicting it or not. Now let's give the input. So here we have tenure as 62. Online security is 0. That means there is no online security. And here we have online backup 1. Device protection 0. Technical support 0. And contract is 1. And the other one we have is monthly charges, that is 98.45725. And the total charges that we have is 5002. Now click on predict. So this given input, it will be pre-processed at the backend and it will be fed to the train model. Train model will be giving us the prediction. And here we got the prediction. So here we can observe that customer is churned. Customer left the services. That means the customer has been left the business. So here target 1, it refers to that customer will churn. He will not retain in the company. Now let's check with this case. So click on chi-square again. So let's give the tenure 8. Online security is 0. That means there is no online security, no online backup, no device protection, no technical support, no contract. And here we have monthly charges as 95.65 and total charges are 5901. Now click on predict. So here also we got the prediction that customer is churned, that is customer will leave the services. He has already left the services. And now let's try with this case. So tenure is 16. Online security is 1, online backup is 1. That means there is online backup, there is online security, there is device protection, there is technical support. Contract is 0, monthly charges are 19.75, total charges are 2544. Now click on predict. So here we got the prediction that customer is not churned. He will retain in the company. Customer will not leave the services. He will retain in the company. So this is how you need to do the prediction with chi-square feature selection. Now let's check with the SFS. So click on SFS. So these are the features selected on which we will be doing prediction. So these are the features obtained by using SFS. Now let's understand them. So the first one we have is the gender. Gender is nothing but whether gender is male or female, and the other one is senior citizen. So it indicates whether customer is a senior citizen or not. Older customers may have different service preferences and churn behaviors. Then coming to the part of tenure, we have already understood in the chi-square part. So coming to the phone service, so this specifies whether customer has a phone service, yes or no. Here we will be writing. So customers without this service may be less engaged with the provider. Then we have multiple lines. It indicates if a customer has multiple phone lines, having multiple lines may suggest higher customer commitment. Then we have online backup, which we have already known, and contract, monthly charges, and total charges. So now let's enter these values. Click on this one. Here we have for SFS. So let's try with this one. Sorry, let's try with this one where the gender is 1, senior citizen is 0. That means it's not a senior citizen. Tenure is 58. Phone service is 1. That means there is phone service. 2 multiple lines the company has and no online backup. 1 contract value is 1. Monthly charges are 104.65 and total charges are 5051. And now let's click on predict. And here you can observe, right, that is customer is churned. He left the services. So here we can observe that we had target 1 and the application is also correctly predicting that customer will be churned. You can observe, right, the application is correctly working. I mean, models have been correctly trained. So now let's check with this case. So the gender is 0. Senior citizen is also 0. Tenure is 72. Phone service is 1. Multiple lines are 2. Online backup is 2. Contract is also 2. Monthly charges are 115.8 and total charges are 6,200. Now click on predict. So here we got the prediction that customer is not churned, customer will not leave the services. That means he will retain. Let's check with this case where gender is 0, senior citizen also 0, 42 is the tenure and 1 is the phone service. Multiple lines are 1, online backup is 0 and contract is 0 and monthly charges are 104.2219 and total charges are 3747. Now click on predict. So here we got the prediction that customer is churned. He will leave the services. That means he has already left the services. Now let's check with the graphs. So let's see the graphs for chi-square feature selection. So here the first graph which we have is the sample outcome graph. Here on x-axis we have the target class that we are predicting, and on y-axis we have the count of each target. So no classes are higher than the yes. So that is why we have used data balancing technique to address this class imbalance. And here we have the correlation matrix graph. This is the correlation matrix, and here we have Shapley value. So this is the XAI techniques feature importance graph, and here we have accuracy score comparison graph. Here on x-axis we have accuracy score, and on y-axis we have all the algorithms that are trained on the features selected using chi-square. Similarly, here we have precision, recall, F1 score. Now let's check with the graphs of SFS. So click on SFS. So here the first graph we have count 1, and here we have correlation matrix. This is the SHAP value graph, and here we have accuracy, precision, recall, and FN score. Now let's sign out. So click on sign out. In this widget, by giving required inputs to the application will be predicting whether customer will churn or not by the trained models. So this is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.